Restream, got a signal. Twitch. Go on Twitch. I'm relying. Yep. Wait. It twitched. Let's refresh. And Twitch got a signal. And YouTube is also streaming. Okay. We are going 3 platforms. Do I trust the audio? I guess I'll have to. Let me know if the audio isn't good. So welcome to the Code Hangout number 220. We're going to take another stab at the counter anti-cheat. Last time we've built some basic tech, sort of proof of concept. I had a chat with the Clemson folks about classroom use, so I have a bit of an idea of how I want to tune the penalties to make sure we're going to include, exclude the right things. There is a technical issue with double taps, but double sends from the client side. I've seen them a couple of times when I looked at raw logs, but I think we need to look at this a little bit more. So what I want to do is I want to have a solid framework where I'm using my backup logs to basically simulate traffic and then see how the penalties work. Icky, thanks for stopping by. I'm generally well, but my nose sometimes just goes bonkers, and it just decided to go bonkers. So if I have to blow my nose a couple of times, I really apologize. Sometimes I think it must be related to stress when I start streaming or when I go inside or outside. Maybe it's humidity, I don't know. Suddenly just goes brrr. Produce fluids. Anyway, I'm not sick or anything. It just does that. To be honest, I've been blowing my nose for like 15 years straight now. I saw a doctor once. He said I have nerve damage, so who knows. All right. Anyway, we don't actually need this right now because step 1 will be to analyze log data. Step 2 will be to see if I can slot it into the running server process without affecting the existing system. So the idea is, not this one. I need to remember which one. Not this one. Let's close some of these things. Let's close that. Let's close that load counter. What is that? All right, let's close all of these for now. The server process is in the API. Oh, wait, we had that open in the other editor here. So, in the API server, right. Okay. Not the thumb stuff. The counter stuff. Here we go. So, here, we need to interject, I think, only the counter increment function. Excuse me. So currently, oh yeah, and I was realizing it's writing the whole file every time the count increments, which are this file is like 40 megabytes right now, so we might want to look into throttling this a little bit so it only updates the counter, like saves the files to drive every minute or so at most. But that's not what I'm looking in for now. So what I need to do is, so we don't actually care about save. Do we care about set first count? I think that's an internal thing. So we have set counter value. Let's see where that comes from. Handle root, counter increment, so counter reset, we don't actually want to throttle or anything like that. That's API protected anyways. All right. So we really only care about the counter increment for now. We might want to add temporarily some logging for other counter API calls. And basically what I want to do is I want to just interject before the bed ref, I think. So basically quite early on, somewhere around here. Well, I guess we could do it after the bad ref since we're doing that anyway. So basically we want to run it in parallel and log information to a file about things that are happening, right? And maybe every hour we might write out the current status of things. I don't know. or if we're logging as the as our round robin table changes. We'll see. But basically what I want to do is I want to run this on the server for a week or so without adjusting, like without touching traffic. Now, one of the issues I've had is that I've made some changes here that haven't been synced correctly. And I don't want to mess up what's online. But I think the API server doesn't have any of those. So as long as we're only touching this file, we should be okay. Okay, so that's later today, not now. And I don't think we care about this file at all. And that's just one of the log files. Okay. So, I think the last thing we were doing last time, I was reorganizing this a little bit, and I was working towards creating these specific objects here, the simple index, the counter queue. I don't recall how far we got. I don't think we're actually using them yet. Yeah. So, the simple index is supposed to be an index of items, and we're going to use that for the counter IDs. And yeah, so the main functionality of this is basically it's just going to have an array of items and an index of so we can reference each item. Yeah, so we can turn items into numbers and numbers back into items, right? And the tricky part is that we want to have a way of clearing it when it's not when things aren't needed anymore. And this stuff needs to be efficient, right? So let's see where the work actually happens. Check penalty, is that our... let's see, where's things happening? I probably commented out the actual work. No, here we go. We're adding item. Row slice, 2 million. But there's 92,000 here. All right, let's go through 10. Right. And just look at what happens, right? Yeah. So we're adding these items to our little round robin. And it executes check penalty. And it does the watch list stuff. Okay. So all right. So the first step here is we're normalizing our, like, okay, so the first step, let's pseudocode it, right? We want to check that the data is good. For example, at the moment, I'm not dealing with IPv6 addresses and things like that. I could use just the strings, because right now I'm counting on being able to reduce the IPs to 32-bit numbers to save space. Let's go with that for now, because I could just treat them as strings and then I don't have to worry about IPv6, I guess. So add item does check penalty. So we kind of want to do this internally. Yeah, so we want to pseudocode this out first. So we have add item check penalty. We have a list of penalties, but everything actually starts over here. So let's write out some pseudocode. So step 1, normalize data, right? Or not normalize, what do you want to call it? Sanitize, right? So our first level is that everything, no, when we have a hit coming in, first we check it for penalties. Right, because only if there isn't already a penalty on this do we actually handle it, right? So we'll check for penalty. Right. For else cut. Or let's say if penalty go to X, else if penalty go to X. We don't know what X is yet. Right. So we have no penalty of any kind. So now we're gonna record. We'll record in the list. And our first level of penalty happens if they're already in the list. Yes. So the second time we're seeing something, we want to check it against the list, the existing queue. Right. So if in queue gonna go to Y, right? And for now, Y will be apply penalty 0, right? And then for add to queue, right? And then X basically is update penalty. Oop, I did not want to go there. Right. Now, adding to queue. Sorry, excuse me. So for our queue, we want to have the simple index. And I think I want to build this simple index independently first. Right. So we'll call this the whole system is like I don't know. I don't want to worry about counter tools lib. We have that already. All right, never mind. Okay. Yeah. We can just put that in there. Actually, let's put this up here and this down here. Then we can move the simple index here. I think export. Does this work? No. So this needs to be a const, even though the return value is a function, right? So I think what we're gonna do here is test simple index, right? And this will just be a function that takes config, and we're just gonna run some tests in here. Like that. All right, and then out of the tools, we'll grab simple index. Right. So, let index1 equals new simple index. And simple index doesn't take any argument, it takes items, but that's fine. Simple index. Right? Okay. And in the simple index, we want to be able to add a bunch of items. And I guess for now, we can just grab some of this test data. So let's move that into a function. Load test data. And we'll basically just bring this thing in here. And I guess this can go in here. Read filtered year, read log file. IPs. Rows, IDs, IPs. So basically this stuff. And then return rows. All right. Let rows equals config. Rows.length and rows 0. We don't want to output the whole thing because it's like, if it's 100,000 items, it's going to take forever. Right. So yeah, so we have 92,118 items, and these are these log lines. And they'll work for the other test as well. So let's make sure we don't duplicate the code. Get rid of that. And then we can just do this up here. Then we don't need any of this stuff. Like, we can get rid of all of this all the way down to here. And here we can say let rows equals await that. And this can actually also go in here. Yeah, this will still run the same way. And then later on we can worry about all that. Okay. Go back to our little test here. We get 92,000 rows. And normalize IP string. So right now, all I really want to do is test this index. And the index doesn't really care about the data type, right? It's just an index of things, of JavaScript things. Excuse me. So we'll just do something like for row of rows dot slice 03. Right. Let me make this a bit bigger. So we'll get some three random rows here, and we'll now just add these to the index. So we'll do index1.add row.ip. And right now, we're just going to add the IPs. Then afterwards, we're going to output the index again. All right. So the index will have these 3 items in it, and they will have 3 IP addresses, or 3 index numbers. And what we want is that I can give it an IP and it gives me a number, and it'll always be the same number. Now, one of the issues I have is when we're clearing it, are we going to fill in the gaps? Are we reusing IDs? Ideally, we don't, but then the numbers might get large. What we could do is we could do a re-index event at some interval, right? Although, yeah, we'll have to think about that. Because the problem is, even if we have, let's say, I don't know, let's say I have 1 million users in a month, 1 million unique IPs. The ID can get larger than that, because if we have a running, it'll just always increment every time there's a hit, right? So it's not how many unique IPs it is, it's how many times this API is being hit. And if somebody's DDoSing it, the ID could ramp up really fast, right? Although it'll hit the penalties and then it shouldn't ramp up. It shouldn't be a problem because the number can get really large, but we'll have to do some math to make sure, you know, it makes sense and it's sane. Okay. Now, the index does nothing special right now. It accepts an array of items. We'll probably don't need that because we'll always kind of add 1 item at a time. The only time we want to add more items is if I'm like pre-filling it for testing. So I think I'm going to remove that. We want to keep the code super slim and super basic functional, right? We'll just check if it exists. If it exists, if it doesn't exist, we'll add it in and we'll assign its index number. Otherwise, we'll just return the index number. So adding an item will just get us an index. And we'll probably want to have a get index, which does the same thing. I mean, add and get index is kind of the same thing. Like, there's only one set get, right? Because getting an index for an item when the item isn't in the index, we kind of want to automatically add it, right? So our add is really a get set. Set get set. Because it does both things always. And there's no reason to ever do it otherwise, right? There's no reason to say, don't, let's see, get that. Like, there's no reason to ever not insert the item. We'll want to have a check, right? So, contains. Return, boom. So we kind of want to do that. If not contains. And then I guess we can do an insert, like a naive insert function. That's the body of that. Which is basically just these two lines without any of the checks. And then we could have a naive lookup function. Which is basically this. And then this would be just this dot lookup, right? But it's a simple thing. We want it to run primitively, so we might not even want to do that here. Yeah, I think I'm not going to do that actually, because the whole point of this is to be super efficient and simple. So we don't actually need that. And I don't think we ever need a contains function for this stuff. The only thing this index does, what we will add is later on, is things for removal and cleaning up, right? So this, we have an index here. And the only thing I'm tempted to add is like a conversion function to convert the IP addresses to the normalized form, right? Normalize IP. So normalize, I think it's actually here. So it takes an IP string. Okay. So then here we want to have a function that does normalize and convert. Export function. What do you want to call it? What did I call it earlier in the pseudocode? Not normalize. Sanitize. Okay. Sanitize IP str, and then we'll basically do the check. So we normalize it. So we'll do something like this. All right. If equals undefined, return false. Otherwise, return IP to int. Boom. And then here, we probably want to pull this in here. Then here we'll say let IP equals sanitize IP row dot IP. And then this should be a list of IP numbers. Now, one of the issues we might have is that if I do this, it might be a little tricky to later on compare the IP address back to the log row. But I don't think that's something this is going to be part of this system. And I think I was deciding to use server times for the live system, but then basically for testing be able to pass in the timestamps from the log. Okay, so the question now is, oh, the index is gonna be like that. Yeah, so I don't actually want that, right? Oh. I'm wondering if this makes sense versus doing an array index off on an integer array, on an array with elements in it. Like index off might be very, very fast, right? Let us put 1,000, like we said, we're going to limit it to 1,000 items, right? So let us put 1,000 items in there. Let's start with 100. What happened? Oh, because we're not doing the getting setting. Okay. Okay. Let's time it. Let n equals 100. N items dot something like that, right? 0.52 milliseconds, and if n is 1,000, it's 1.39 milliseconds, and let's go 10x, right? All right, so for 10,000, it takes 9 milliseconds to add them. So let's time how long it takes us to look them up. It feels like this is not a good measure because doing anything at 10,000 times should be actually super fast, especially stuff like this, very simple stuff like this. So we might have to test it both ways to make sure there isn't any weird caching happening. So if we do it a second time, let's pull the items out into a separate array. In fact, let's do this up front, right? So let's say let test IPs or const test IPs is an array. Then we do this. We'll grab that. We'll push them into this, right? The sanitized IPs. Right. And then here, here we'll just run through them, right? So for test IPs. Now we don't sanitize them, right? We'll do that. Okay. And then we'll kind of do the same thing for the lookup. Then we'll do this. And here we'll do say const res equals array n. And then we'll say let's just make this a proper loop. So we don't have any weird array overheads and stuff. Right, let's do a small test run first before we'll go full hog here. And then at the end, we can also output these. Res, boom. And the res lookups should be our index numbers, right? So 50 lookups, yada, 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 right? And let's do that. So we can get kind of first and last element, sure. And if we make this 1000, it's doing that. And if we're doing 10,000, six 0.681 milliseconds, and before it was 0.08. So it does get slower. So that's when we're doing this kind of slow lookup. Right. And now if we're doing this with index off, you know what? We'll just do a res 2. And then here we'll just say items dot index off, and it should just give us the same values. And it should be slower, right? Yes. So it is significantly slower. Maybe 15 times slower. And 12 milliseconds is not insignificant. Now, we've done it 10,000 times. That's not what's going to happen. Usually we'll do it once, right? And our length, we're thinking, or I was thinking around 1,000. Because if I look at a heavy traffic day, let's say yesterday, we have a total of 72,000 page views. Now, the counter increments will be less. Counter increment should happen when there's a puzzle solved, right? So 22,000. And each time we'll have to do this probably once, but we'll have to do it for both lists. Wait, what am I thinking? So 22,000 averages to just over 1,000 an hour. So a list over 1,000 will roughly give us an hour coverage. But of course, we have a load time of 500 and a high time of 600 to 1.9. So on the busy time, and this will obviously go higher on other days, 1.3. So let's say on a busy time, let's cap it at 2,000. So on a busy time, our window will shrink to half an hour, unless we just use 2,000 as our baseline, right? And an index off on an array of 2,000 numbers takes just under a millisecond. Versus 0.1. I mean, it saves us 0.6 or 0.5 milliseconds. If we do 2,000 times, which we're not. So it might actually not be worth doing this. To actually build indices. Let's try it on... Let's rename these. Let's try it on the other type. So instead of row IP, I think this should run the same. Test IPs, test items, test IPs, test IPs, test IPs. So if we look at row 0, the other one should be counter ID. So if I just change it to counter ID and use the strings, and let's do it this way. Get rid of the sanitize IP. And now for 2000, I just want to check if index off on an array of strings is significantly slower in any way. 0.7, 0.35. No, it looks faster, but that could be just error range. So I don't think it actually makes sense to index as like this would make sense if this is like an inner loop and we have to do this many times. But I think we only need to do it once. So maybe having the simple index here as its own structure is actually silly. Although we could just abstract it away, use the simple index, and internally I just do an index off instead of storing the data twice. Because I'm thinking the advantage is that I can store a lot more if I don't store it twice. I could just store twice as many items instead of storing both the index. Like, in other words, is speed more important than memory consumption? And while I want to conserve performance, I don't think this significantly impacts what's happening on the server. Probably saving 40 megabytes and zipping it up every time a hit happens will be much more expensive than doing an index off on an array of 5,000 items in JavaScript, right? So I feel like I'm completely barking up the wrong tree here. So I think we're gonna move on to the next item, which is the counter Q. Again, do I actually want this as a primitive, or do I just want to start building the actual thing? So according to our pseudocode, we want to sanitize, check for penalty. All right. So here I feel like our data wasn't very clean and we had a lot of this stuff going on. So we probably want to get rid of all of this. I don't even know what I was doing here. Oh, I was still checking the IP stuff. All right. I think I'm just gonna say, I'm just gonna call this start 2. We're just gonna continue from here. We're not gonna use the simple index at all. So we're basically just gonna do this. And we're just gonna implement the now new idea of, well, not new, but the algorithm as we think it should be, right? So I think what we actually want to do is get the test data out of here in a certain way. Because one of the problems I have is it's easier to test with less data. But when I have a small amount of data, I might not encounter any of the test cases, which is multiple IPs. So I might actually want to synthesize some test data, if you know what I mean. So for example, if I get 10 rows here, so we might want to create synthetic test data. That's what I'm trying to get to, really. If I just output these 10 rows, right? So count IPs, count IPs. So it's a new set, rows.map, row.ip, like that. That gives us an area, I believe, right? And if we get the length of that, it's 10, right? And if we go to 100, it's 97. So at 100, we'll have some duplicate IPs, which is kind of what we want, right? And we'll do the same thing with counter IDs. Now, what I don't know is, in those repeats, do we have repeat counter IDs? Basically, I want to do a statistical analysis. I'm kind of, it's a chicken and egg. Do I first want to statistically analyze the data that I'm testing on, or do I want to just build the algorithm and then run the data through it and it'll show me what's happening, right? I think this tells us that 10 items should be enough. Right. So now, basically, we just want to have, and I think I can just build this here, right? We can look at our pseudo algorithm here, our pseudocode. We'll actually bring it down. Right. So sanitize data. So each row is the date and time we'll need as well, right? Now the sanitization still needs to happen, so we don't want that to be expensive, but we can then afterwards run it, you know, 1,000 times and see how expensive it is. All right, so for row of rows, let's shrink it back to 3 just to kind of take a look. Then here we'll say let IP equals sanitize IP row.ip. Counter ID equals row.counter ID. And dt equals new date row.date. Now that won't be part of the actual test, because that date time should come out of our server clock, right? So we don't actually have to generate a date object for each row. But that gets us the test data. We don't need that, so we can kind of look at this. So we'll get an IP as an integer. We'll afterwards check that it all back converts, because I think these are 64-bit integers, so we shouldn't have any problems with the byte conversion. But it might not even be worthwhile memory-wise, because it's 64-bit. It's already 8 bytes versus an IP string, which is at most 12 plus 3, 15. I mean, it's twice as much, I guess. It probably doesn't matter. We'll see. We'll see. All right. Step 1, sanitize data, check. Right. So we'll put each step here, so we know what's happening. Step 2, if penalty go to X. We'll skip that for now. We'll skip that as well. Actually, we'll just put all of these here. Actually, this can now become 5 and 6. But, whoa. This can be 5. This can be 6. Make sure you let me know if I'm pushing things off the screen, because I'm so used to kind of working with a small font, and maybe I should make things a little bit bigger so they make sense on the stream. All right. Because my display is fairly large and it's higher resolution than what you guys see on stream. So that's 5 and 6. Go to 5. Go to... Yeah, I'm not going to have 2 copies of this. This does make sense. So, apply penalty. Don't know. So, if in queue go to 6, add to queue is what we do next. Right. So we need our queues, or our round robin queue will be IP counter pairs, right? So we'll have IPs IDs, and Q. Right, and the Q will also... The Q, is this just an array? Yeah, okay. So we first want to convert the IP and the counter ID and all that stuff into indexes, right? So IP now I actually do want an index just to wrap the index off and all that stuff. So maybe we will use these, because then in the future we could always easily flip it around. So we don't want that. We'll do that. We'll do that. If index item, if index, if items dot index. So we do let res equals this dot items dot index of item. If res equals -1, do this. So then we'll do this dot items dot push item, and then res equals this dot items dot length is 1, and then here we'll just do a return res, right? And we'll just use the index of as our lookup, and we need to kind of hold a temp value, and that's the only real difference, right? So IPs equals IP IDX equals new simple index, ID IDX, also a new simple index, and Q will still just be an array for now, right? So IP IDX dot oops. Let's write these out and then use the short form. That won't be confusing at all. Use the short form here. So we'll say let or const IP IDX equals IP index get set IP, and ID index IDX is ID index get set counter ID. Boom. Right. If we run this, it should just do that. And then we can just say ID IDX. So these should just be numbers 1 through 3. 0, 1, 2, 3. Sure. Okay. No penalty, no. If and Q go to 6. So now the Q is a combination of these. Okay, so now we'll say we'll also need the Q index. So Q IDX. And this I kind of don't like, because I have to basically combine these two into a string. Because what I was doing previously, I was saying, okay, let's just use the two as a joint index basically into our queue, and I say, okay, well, have we got that in before? This sort of item before. Now I'm wondering if we kind of can optimize things by having a separate list of counter IDs per ID, right? But maybe I'm overthinking things, making things more complex than necessary. So let's just stick with the original plan. So we'll just combine these two together. Let's do that. And that's our QIDX. So now we have our 3 indexes, right? One thing I don't like about this is that as the numbers get larger, this string will get bigger and use up more memory. So it would be nice if we could keep these as numbers. And I guess we could use high bit, low bit ordering and such. But the moment they become... I don't know. I'm thinking right now, if we have an array with two fields, one being the IP and one being the ID, doing an index off on the two, we'll just loop through the array, right? And we have an ON. We're not doing quick sort or anything like that. We're not finding anything more quickly, right? And I guess we want to look backwards because we're more interested in more recent events, right? Like if somebody hits the same puzzle every half hour, every hour, we're not actually that interested. So we might not even have to go through the whole list, right? If we go backwards through the list, we might only scan the most recent 5 minutes. We might never even get through all 1,000 or 5,000 or whatever items. We might just look at 10 and say, okay, well, the last item, or even just one. If the last one, like if nothing happened, I mean, that doesn't really happen on the site, but if no counter was incremented in the last 10 minutes, then we're not really at risk of duplicates, right? But we probably don't want to all special case it like this. All right, so previously, what did we actually put into the queue in the end? I think we need the time of the event, right? So we basically need IP, ID, and time. Yeah. So we'll just say queue dot push ID, put an array, ID, no, IP, ID, and DT. Right. Currently we're doing 3 items, right? So we can just output the whole thing at the end. That will get us the queue. All right, let's change this to ID. Boom, boom. Right. So this is what our queue would look like. So then as the queue gets to a certain length, we'll break it off, yada, yada, yada. Okay. And I'm thinking right now, I almost want to just use the IP strings just for testing until the whole thing works. Because that's like this is probably a case of premature optimization. So if I do this, we don't need to sanitize anything, right? It just looks like that. Right. So, so if I do this, so this is what kind of our queue would look like. We have the IPs, we have the thing, whatever, right? And then the queue will also have a check, right? So if in queue go to 6. Now, for that, we might have to do the whole thing, right? So we don't want to log these for now if we go through more of them. So let's go through 10. I think at 100 is when I started getting duplicate data. I guess we can just do 100 here. I don't think it's too terrible if we output that. Yeah. Okay. Because now we can say, okay, can we find this, right? So we can do a function here. Const. If we yeah, I think we want the index because we might have to manipulate that item in the queue. No, not really, actually, because we're not... I don't think we're gonna touch what's in the queue. Because once somebody gets on the penalty list, I think we'll track them separately. No, we won't track them separately. They'll still go into the log. Because I'm currently thinking, are we going to consume all of the queue if somebody's spamming it, right? Because I was thinking, originally I was just going to add it to the queue anyways, the item, because then we don't have to worry about renewing the item. But actually what we really want to do is we want to keep the most recent item in the queue. No, actually, no. Once somebody's in the penalty list, they don't need to participate in the queue at all anymore, actually. Because the penalty check happens earlier, right? So the queue, once somebody goes on the penalty list, they don't need to be in the queue anymore. We can just skip the rest. They don't get added back into the queue because we're not checking the queue first, right? We'll checking the penalty list first. And the penalty list would then get refreshed every time we get another hit from that guy, right? So we'll do a little function, function in is in queue, right? And we'll have IP ID. If in queue go to 6, right? So here we go. If is in queue IP ID console.log in queue. We do this. We'll do this. ID, IP ID. And here we'll just do return false. So nothing will happen, right? But now we'll actually search for this, right? So we'll go in reverse, I believe, because things get added to the, yeah, we'll go in reverse. So for let I equals q.length, I greater or equal to 0, I plus plus. And let's go back to a small list. Console.log I q I. Right? Ooh. Minus. All right. 0, 1. So the first one, q.length would be 0. Q.length. IQ. What? I'm doing this wrong, aren't I? Oh, Q length is 0. So we'll have to start -1 here. So when the queue is empty, there's nothing. Then we're looking at damn it. Okay, so isn't queue 0? Yeah, we don't want to actually pull that out. So isn't queue. Queue length is 1. We're checking item 0. Isn't queue item 1. When the length is 2. Huh? One sec. So the first time we don't check anything. The second time we check one item. The third time we have 2 items. We check item 1 first and then item 0 first and then item 0 second. Okay. Okay. And at the end here, if I do this, we'll get that. Okay. And then we'll just say if qi 0 equals IP and qi 1. And I don't think I care if the same IP does something on a different whatever, right? We might even join them into a single string. No, I don't think this double comparing 2 short strings versus comparing 1 long string. I'm not sure that makes a difference. Equals ID, return I guess. Right? So now we won't get a match, but if we go to 100, we should get 3 matches. Where are we checking? Where does this come from? Is that us just outputting the first row? Yeah, let's get rid of that. So we don't actually have an IP and ID match in the first 100, maybe in the first 1,000. Okay, we have 1 match. All right, and here we can say rows.index of row. So at row 295, we're matching row 243, right? Actually, let's make this a little bit more verbose. We'll output row, and we'll output rows in queue. This in queue. So this matches this. And this happened at 13 minutes, 21 seconds. This happened at 10 minutes, 36 seconds. Now, this one is the smaller number. Yeah, so this one was added first. So we're basically hitting this guy at number 295, and it matches at 243. So this is exactly what I was talking about earlier. So here we have a case of the same guy getting hit, the same counter getting hit twice by the same IP, 3 minutes apart. So I strongly suspect this is a error in the client-side software where it, for some reason, maybe it's an incognito tab or whatever, right? Or maybe the same person opened it in another browser and it just misfired, you know, I don't know. But this is actually stuff I want to also detect, right? So we get a detection, and then we want to go to 6. We want to apply the penalty. We still want to add... Do we still want to add Q? No. So actually here, we want to, if we're in Q, we want to handle the penalty. So this Q push is actually all is an else. Right. So we're in queue, but we're not in penalty yet. Okay. So we do create penalty. Now, in the create penalty, do I want to pass in both? Because I'm trying to think, is it enough to prevent the second hit? And then we don't really care about the details. Or do we care about how far apart they are? I mean, I'm trying to think here if... Yeah, no. I'm thinking I'm barking up the wrong tree, because I was thinking like, oh, is there a timing where we don't want to apply any penalty? No, because this is supposedly a completely unique event, right? With a presumption that the log data is accurate, right? The log data is standing in for real events, which means, in theory, this real event needs to be handled correctly, and the counter should have been incremented already. And we don't have a record of that happening. We just have to trust that it happened. And if it failed, it's likely to fail again anyways. All right. So at this, we're creating the penalty, and we don't care about the details of the two hits at all. We're just saying this is the first penalty, and for now we'll pass in the 3 bits of information here, right? So IP, ID, and DT. The current time, right? So now we'll have a function create penalty with a DT, right? And then here we'll have a list of penalties for now. The penalties might make sense to index them by IP, right? Because at that point we don't really care about, well, the penalty is, this is something I'm still contemplating, is if somebody gets hit by this, do we want to penalize all their interactions with all puzzles? Probably not, right? Because this is also supposed to be correcting for technical issues from client-side code, right? So we don't actually, I call it a penalty, but it really doesn't, it's not meant to penalize the user, right? It's meant to correct the data, right? And I might rename this in the final code. We'll just call this create watch, right? So we're just creating a watch item. Or let's call them guards. because we're potentially guarding against this guy, right? Console.log. I think this is gonna happen only once now. And then we don't need to do this. Boom, right? We have a crate guard on these 3 pieces of data. Right. And it's gonna be indexed on these 2. And because we're checking earlier, at this point, there should not be a guard on this one yet. All right, so we definitely need to test data with more than 1 guard. Sorry, more than 1 bad event, right? We said this happens between these 2 IDs, right? Between row 2495. So we kind of want to output these 2 items in the order that they're likely to have happened, right? So if I go to 240 and then 2000, we have an in queue at 3. All right. If I go to 5000, do we get a second one? So these are all new guard items. I don't see any duplication here. Ah, wait. No. So we get double hits, but not... no triple hits, because this is on a different puzzle. Okay. So I think we also want to do the penalty check. So if guard, go to 5, right? If in queue... If in queue, create guard. If guard, update guard. Right. So we basically want to have a function check guard. Right. So we could say let in guard equals check guard ID. And I'm wondering if we can reduce this to a single check. Back to if our queue is actually annotated with this stuff, then we might not have a separate, since we're searching through a list anyways, what we could do is the queue might actually contain the guards, and then we're not dropping them off the end of the queue, basically. So our queue trimming algorithm, ideally we would move it to the front of the queue again, whenever there's a guard update event, right? So what I'm thinking is, like, you have your queue, right? The items kind of flow from back to front, get knocked off the back. But whenever there's an event, if we knock it back to the front, the problem is that's potentially a whole bunch of memory copy. So again, maybe this is premature optimization, but that might actually not might not be an efficient way of doing it. Because we could go from the item to the front and copy each item back 1 item, pointer, everything. I mean, if I knew what the pointers under the bonnet are doing, it wouldn't be too bad. The alternative would be to store the items separately from the queue, and the queue is just an array of indices, right? And then in the separate item, we can update them there, and we can index by, have an object indexed by IPs, because we mostly care about the IPs. And then when we're rearranging things, we're just doing ID number swaps or something. I don't know. Probably overthinking things again. So we have this in queue. Let's just call it check queue. So call this check queue. Boom. So we have check queue. And then we have create guard afterwards. But now we'll have check guard as well. I don't think I want to do this because I think it's gonna do that. Yeah. So when we're checking the guard, it needs to be fast. Now the guard list should be relatively small. And I think the guard list can be indexed by IP because all the penalties on the IP, right? Do we accept multiple penalties for multiple counter IDs? I suppose we might have to. So, okay. So if I say guards IP, that should be our result from our guards check, right? Boom. So if guards IP equals undefined, return false, else return guards IP. Right. If in queue, sorry, if in guard, we don't want to actually do the rest here. If in guard, or has guard. Is this how you spell guard? Guards. I've said it so many times now my brain doesn't recognize the word anymore. Guard. Yes, okay. It's that phenomenon when you say a word over and over and over, eventually it doesn't sound like a real word anymore. All right, so if has get guard yada yada yada, else we'll do this. How about we'll make some variables up here. So let has guard in queue. Right. So then we can say if has guard blah blah blah, else if in queue, else if in queue. And for some reason that spacing just bothers me. Here too. All right. So check guard, we're just gonna output has guard. Boom. Now, I don't actually expect a match here in queue. All right. So check guard. So check queue happens 3 times. Then we're hitting create guard, where currently we're not really creating guards. So our presumption is that we're already safe at this point, right? So that's the second check. So the guards list always gets checked. So every item gets checked against our current penalties first. So that check needs to be the fastest. Right, create guard. So guards IP equals ID DT. Whatever. So that creates a guard item here. And now if we run this for longer, much longer. Okay. Much longer. Okay, so here we got 2 create guards. So check queue, create guard, check queue, create guard. Okay. I probably want to do these the other way around. create guard, and then check guard doesn't happen. So check guard. Okay, so this test data, we don't have multiple hits yet. Okay, so then eventually we're hitting check guard. And then here we need to sort of escalate, right? Level 0, right? And then check guard. So has guard. Let's do these like that, so they all make sense to us. So has guard is here, level 0. So if guard, update guard. Okay, so just like that, we'll update guard. Guard. I guess this is just guard. Right. Then update guard. Create guard. We want update guard. 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 We do want to have the IP in here as well. Otherwise we'll need some sort of reverse index, right? And we'll have update guard with guard in here, like that. Update guard. Update guard. All right, now outputting the whole thing doesn't make a lot of sense. It's just gonna be spammy. We don't actually need that, and we don't actually need that. Right, so create guard, update guard, boom, right. So update guard currently we're just gonna increment the level, right? So guards, guard.ip. Now here I'm currently not worrying about the IDs. We'll sort that out in a minute. Okay. So in the moment, we're just gonna increment level. Right. Now, check guard. If guard, update guard. Update guard increments the level. So right now, if we're hitting this, we don't do anything else. We're updating the guard, that's it. If we're hitting this, we're creating the guard, that's it. If not, we're adding to the queue, right? So check guard, check queued, and then function, create guard, update guard, function, add to queue, and that'll be IP DT. Hi guys. Sorry, IP ID DT. And it'll basically just do this for now. So here we'll do this. And that. All right. Now at the very end down here, okay, so that doesn't make sense anymore. So I think we're pretty much one-on-one here with our pseudocode, right? If blah blah blah, update guard, else if create guard, else add to queue. And then at the end, we'll output the guards and see what it looks like. And we'll get a couple, and one level is level 3, right? Now, here we don't have the actual individual log entries yet. So now we gotta say, okay, we're gonna do this by, we gotta check by IPs, right? So check guard happens after create guard. So create guard is in order of things happening. So add to queue is the most primitive. So that happens first. Right. Then create guard. Right. So when we're creating the guard, we have our IP, but now we actually want this separated. Right. So we'll call it guards. And right now it'll just get an array with one element in it. No. So the guards are I think this needs to be part of that, right? So update check guard, update guard, check queue create guard. So create guard, we'll actually make it part of check queue. So instead of here returning right away, we're actually doing the create guard. Or do we? Does it make a difference? In queue, if because ultimately this will be one function call. I'm just let's just do this. So create guard, because I'm thinking I'll have to loop twice, right? Because check guard, we got to do this. If that's return false, guards return guards IP dot IDs ID. Right, and then create guards will be because create guard is specifically when we've not checked, so they're not at all. There's not a single guard for this guy. All right. Whew. All right. So I'm getting around to it. So IPs will be an object, and we're adding one element, which is using the ID as the key, and this as the value. Right. Like that. And now, check card has IPs to check against. I think actually we can just do this, right? Does it have to be this? Can we do this? Oh, that's silly. Return guards.ip is not equal to undefined, and guards ip.id's ID is not equal to undefined. That's really what we want to return, right? IDs, not IPs. There we go. And then check guard is that. Update guard is here. So update guard happens never, right? Not on this test set, right? So we get 5 create guard. Wait, no, update guard should happen. Yeah, no. I don't think we actually had a duplicated IP there. If we start from 0 here, what does it look like? So we just have a bunch of create guards. So we'll get a check guard. check guard. So check guard never comes back like that. Okay. So that's just false. Update guard. Oh, wait, no. Because we're not returning the guard value? Wait. IDs. Object. Check guard. If console.log check. We're checking IP ID against guard's IP. Am I being stupid here? I completely misspelled that. I must be stupid. Yes. Oops, I don't think I muted that correctly. Sorry about that. That must have been nasty. All right, so medium hard. So maybe we don't have any checks. All right, I feel like I should have gotten my synthetic test data better organized. Okay, so now we're getting an update guard event. Right. So we have a check where we're checking this IP and this against that, and we'll get a match. Okay. Okay. Update guard needs to know what we're updating. So we're kind of updating IP ID DT, right? So IP ID DT. Right. Then guard. Guard equals check guard IP ID. But check guard currently doesn't return the thing, right? So what we can do is return this and this question mark. You know what? I'm going back to what I had before. So if this is undefined, we just return false. If equals undefined, return false. If .ids equals undefined, return false. Else return this, right? And there's probably some optimization we could do, but let's hope the runtime optimizes that for us. So check guard returns the guard. So check queue, check guard. So this is our guard. If we output guards IP, what does that look like? So we have this under this, and then this. Okay, so we can just say guard.level++. Boom. Don't need that. All right. So now some of these should be level 2 or whatever. Let's see what that looks like. All right, it's already 8:30, guys. The stream can't be as long as I would like. I got a late start. I planned to start earlier. Things happened out of my control, I'm afraid. Yeah, so we have a level 2 hit here. And now we have to kind of decide how we handle these. what I want to do is I basically want to have a timeout fade off thing for each level, right? But before we do this, we still need to, excuse me, we still need to deal, so we have create guard, right? And we want to output update guard as well. Guard JSON.stringify guard .ids ID, something like that. Guard IP, no, guard is already by IP. Guard.ids. Wait, what is guard? Update guard. Oh, it's already the sub item. Okay. Okay. I think the only reason I added these in here is for the back reference. But if we're not using the back reference, then we don't need that. So we don't need IP here. And we don't need ID here. And that'll save us a whole bunch of storage. Right. We don't want that. We gotta assume this is functional. We shouldn't. These will get combined into one function later on. So we can make this assumption that these are always functional like this. So now the question is, do we care about the individual timings over a period of time? So because my original thought was I could now that I've reduced this, you know, from 10,000 items to 15, I could keep complex logs on these, right? But in reality, maybe I don't need to. The other thing we need to know is what our queue looks like. So if we look at queue.length, so if we do this, right, our queue length is 9,981, right? So if we say const max queue length equals 500, now we can say, okay, add to queue, and then we'll say if queue, oh my god. Oh, I keep pressing the wrong button. Here we go. The length is greater or equal to max queue length. I think it's unshift, right? Unshift. Is that popping from the top? Seriously? Is that from popping from the top? Really? A reCAPTCHA on unshift? Unshift. Method error insists adds a special at the beginning of an array. No. Hop removes the last element. Okay. Shift. So to remove the first element. Okay, so shift is what we want, right? So basically we want to do while queue console.log shifting queue 0. Oh my god, why can't I type this word? Dot shift. Right? So if we do this, queue length will stay at 500, and we'll do a bunch of shifting. Now, if we don't lock this out, right? We probably have fewer detections now. So if I increase this to 5,000, we have more events. And that's basically now, once we have this running with a whole bunch of test data, that's what I want to tweak, right? But now I can run it for many more, like 50,000 events, right? Queue never goes beyond 50,000, right? And we can also say, see how many guards we have, and we just put a max length on the guards as well. Although with the guards, we probably want to sort of keep track of the highest, what's the word? Offenders. and remove, not necessarily remove the first one. Well, actually, no. Yeah, we can still remove the first one because we'll track some sort of most recent event timestamp on it, right? And then we'll just remove them by that rather than in some sort of queue order. And it should happen much less frequently, so we don't have to worry about what's the word? About performance, right? Because it'll happen, so, 47, right? Over our 50,000 rows, we have a guard length of 47. 47 IPs. It might be more once we take into consideration the IDs, right? So, for example, now we have a level 2 event here. So these are the ones where we have more than, just a duplication. Most of these will basically be errors in my software that we just want to correct. So the next step would be to track the duration of, or literally just to tag the last daytime, which I think we're already doing. The problem right now is that I don't have a daytime reference to the real time. No, I don't need that, right? All I need is a compare to items, right? So when we say update guard, so when we're updating the guard, we want to compare this with the DT in the guard. Right. So we want to do, first we're going to do guard dot, guard IP dot IDs ID dot DT, or that, and DT. Like that. So every time one of these things happens... Oh, the guard item, I keep forgetting. The guard item is just that. So we can just look straight at that. We don't care about the nesting, right? So all we have in the guard item is the datetime and the level. So we should be able to, compare these directly. So if I subtract these, we should end up with a number here. Right, negative number, as it should be. But I'll probably want to protect against out of order log processing or something. But this is designed to be a real-time system, so the logs are just simulating real-time. Real-time should never happen out of order, right? So for example, these happen pretty far apart, while these happen pretty close together. So this is now where I have to say, okay, basically when we're hitting a certain timeout, which relates to the level we're at, we're going to either reset the level or increment. So we'll basically have a list where we're putting in the current level and the duration, right? And it'll tell us, okay, at that level with this duration, it's just going to be a reset, right? In all cases, we don't want to let them re-register, except maybe we want to have maybe a 24-hour timeout or something, right? So this is the next step, right? So let me add this as a thing, blah, blah, blah. So at level 0, right? At level 0, we basically don't do any further penalization. So no, once you're... The other thing I'm thinking is... no. For a second I was thinking, like, because we want to avoid all duplicates, everybody will eventually end up at level 0, and our level 0 will just be a log. But that's not actually the case. We're only caring about people that encounter a duplication within our queue timing, right? So if the error occurs a day apart, we're not actually going to tracking that. We're not going to be tracking that, right? So if somebody hits it every day or whatever, we're not going to track that. If they hit it after half an hour, they might stick in the system for, 6 hours, 3 hours, whatever, right? Level 0 is low risk. So how long do we want to keep track of level 0? We could potentially track for a relatively long time, because right now, it's indefinite, and for our test data, we have a very short guard length here. If we make the queue 10,000 and our test data bigger, right? And that should give us a rows length here of 92,000, right? And ultimately a queue length of 188. Guard length of 188 at a queue length of 10,000, right? And I don't think it'll get much bigger than that. And we could look at the delta, a time delta in create guard as well, because that's our first two events. Except we know that the time delta is within our window, so it's kind of a free error prevention. So we kind of don't want to necessarily mess with that too much. I want to get the full length of this. Let me make this a little bit faster. We want object.values.guards.map, and each element will be an array of IP guard, which we want to convert to an array of IP guard dot object.values my brain. I'm getting tired. So we have guard.ips. This gets us an array of IPs and the DT and the level. So we actually want to map those as well. Map. Right. And we'll basically just want to do IP, like something like that, right? And that goes, I think that'll get us an array of whatever, right? Object is not iterable. Object.value guards. 1 second. What is the guard object here? Object is not iterable. Huh? Object is not iterable. Maybe because we only have one item here. We need a couple, right? So, guards, IDs. Wait, what? Where are the IPs? Object.values. Object dot. Oh, entries. Gosh darn it. All right, entries. Sorry for the censorship. That sounds weird. God damn it. All right, so that's what I was looking for, not values. Okay. Sometimes I try not to look things up, and my brain is just on the wrong wavelength. Object.entries guards. What about that? Guards. Guard. IPs. IDs is what we want. Right? And we have now IP, ID, the rest. I think actually here we just care about, do we need IDs as a property? Because we could just map this directly to the Like, we don't need this level. Yeah, I don't think we need this level, right? So we can just map that directly to this object. And then we don't have .ids. We can get rid of that. So check guard is not then .ids, it's just that. Which is the syntax I've been wanting. I've always wanted the syntax, right? And now we can just do this. IDs. And then we just IDs map. ID. Guard. Whatever, right? IP, ID, guard. Guard is not iterable. Guard is an object. If I do this, will that work? Ay. Object spread syntax. Come on. We should be able to spread an object, right? Object. Yeah. So, oh, we need to bracify that though. Hey, look at that. All right. So IP ID DT. So this is just a flat version of what we had earlier. Dot. I think we can just do flat map here. Boom. All right. Yeah. So that gets us a flat area of the guards. So let flat guards equals this. All right, and then we can just say dot length like that, and 6. Great. And over our larger run, we'll end up with, we had 188 before, and now we'll have still 188. So that means we don't have in this data set, we don't have a single person that hits foul on more than one puzzle, which is sort of basically expected, right? Can we enlarge this data set then? If I do this, it's gonna hit the whole thing. So that's how many rows? Limited to 100,000. All right, 500,000. Boom. 202. Look at that. Just those extras beyond the 90,000 already gave us a couple of extra guards. So we got a level 11 there. We probably don't want to hit, we don't want to output create guard because there's just so many of them. Those numbers are from the update guard. Okay. So first of all, we're going to put that number into that there. Kind of like there. Secondly, we're going to do remove create guard. And now this is probably one of our cases. Yeah. So this is, oh, we're gonna hit level a gajillion, right? And that's our spam case, right? Boom. All right. And even then, we only have 674 guards in the end. Now, processing all this data took a little while, but part of that is also parsing, and it's actually quite a bit of data, right? It's you know, I'm guessing it's all of these. So it's, you know, 23 megabytes of zip JSON data, and then we're doing a bunch of stuff. Okay. But we will performance finagle it, right? The important thing is we don't want duplicate log events, right? So logging happens here. So the queue here is 10,000. That's fine. We might keep it smaller. We'll probably run a bunch of tests, right? So for example, if we make the queue 2000 and run the same thing, I probably should time it actually. And then this is where we get our 40,000 hits. And eventually the level shouldn't go up, right? Like there's a limit of how high the level will go. Yeah. So here the guard length went to 450. Before it was slightly less, but not too much. So we can kind of fine tune and say, okay, how many will slip through if we're reducing the queue length, right? And if 1 or 2 slip through in a whole month, that's not a big deal. And we can make it longer as well, right? So we can say, okay, let's actually do this. So if the guard is, we'll just say if guard.level is less than 100 or less than 10, really, because once you get to that level, we don't really care anymore. And now if we make this really large, we get a core dump. Wow. Oh, JavaScript. Although that might be my computer's problem. I have some memory issues I need to sort out. Because that core dump was not an out-of-memory error message, if you've noticed. And we wouldn't have hit that queue length that quickly anyways, right? Because the queue could never be larger than that. What I don't know is how expensive this process is. I mean, alternatively, we could just have a fixed length array and we'll just have a pointer that says where we're reading next, right? Yeah, we could just round robin it from here. The queue right now is IPID. I wonder if having a branching queue might also make sense. Not really. So in my, if I remember my computer science properly, what we want, and maybe I can use Paint for that. Gonna pull a Thor here, Pirate Software. Basically what we want to do, yeah, okay. Can we invert that? I do that, and then we can just kind of do this. So if we have a queue like this, right? What we can do is we can have 2 pointers, head and tail, right? And then as we are adding an item, we go forward, until we hit this, and then we'll just start overriding what's behind, and we'll just keep track where the 2 are. I guess tail will always stay here until it hits it, and then we'll push it forward. And then we can go loop through it backwards until we find our match here. And then we don't have, I don't know how expensive shift is. How expensive is array shift in JavaScript? And a linked list equivalent JavaScript, sure. Array shifts are slower than equivalent on a linked list. 100% slow. Okay, so it's actually kind of slow. Again, premature optimization, right? We don't really care about that. That should be just black box, right? And then we can optimize it later. I mean, the other thing is that I don't like right now is we're having multiple copies of the item, but not that many. Like before we saw, we only had 450 guards up. So the data duplication is very minimal there. And that's like a month worth of data, right? So we can keep a month's worth of guards in memory, no problem. 450. Multiply it by 10 for a year, roughly, right? So 4,000 or 5,000, not a problem at all. And in the future, you know, it might go up. And then we just limit it. And we say, okay, you know. And to be honest, now it should actually be smaller. Why is it taking so long? Oh, yeah, because I increased the queue up to 100,000 items. Is that? Yes, it'll make it slower. My justification for using index off earlier was very specifically because I presumed we'll have a relatively short queue, 1,000 to 2,000 items. To be fair, the queue, keep thinking like, do I want the guards to be entirely independent of the queue? Because once you found an item in the queue, that should just reference the guard, right? Except the difference is, or the point is really that in our algorithm, we're checking the guard first. And here, for example, we don't actually need to hold these as results, right? Right? So check queue returns something, but we don't actually care. So here we can just return true. Right. Otherwise return false. And check guard. The only reason returning this makes sense is because we're using that here. Yeah, it doesn't make sense to have the queue items linked to the guard, because there's so many more of the queue items. It makes sense to optimize the queue itself. The more optimal our queue is, the more we can put in the queue, right? So, I'm not even using the queue index here at the moment, but what I'm thinking is, instead of having the queue being this, now let's add to queue. So instead of doing this, and we don't use the DT from the queue anyways, right? No. We're only looking at once we're in the guard, right? So check guard. Wait, check guard. Only IP ID. Check guard. Check guard. Yeah, so when we're creating the guard, we already... Yeah. Okay, sorry. We're kind of ignoring the first delta time. So a long queue... Yeah, that's fine. Okay, so I'm thinking we don't need the delta time in the queue. So actually, we don't even need to add that. And then we can turn this into a single string index, and we can make the queue actually be a thingamajig, right? The only sorry, yeah. So the only issue with that is that queue shift doesn't work on object keys. Yeah, and now I'm going round robin, and that's why originally I was gonna have a list of IDs of numbers. Yeah, I think if we get rid of the shift operation and just having the head tail thing, no, I don't think I can do an index and track what's the earliest and what. Like, you don't have ordering in indices, right? Well, we might. JavaScript set. Do we have ordering in sets? Set order. Why is Google struggling? What's going on here? Why is my browser struggling to open Google? I don't know if set is performant. That's the problem. Set may only occur once. As unique. Set JavaScript set elements insertion maintains it. This means that when you iterate over set, the elements will be returned to the same sequence. Is that? But is that guaranteed, or is that just happens to be like that and I can't rely on it? Because if it's important for me, which in this case it would be, new object called set was the set order is to map, but the major difference is that elements in the set are unique, and repeated addition of the same type of element is not possible. Set can store any type of value, whether primitive or object. Elements set are iterable. Elements are always iterated in the insertion order. The elements in the set are ordered, which means that they can be assessed iterated in order of the insertion. So if I say Q2 equals new set, right? And then here we'll say, can I JavaScript queue based on set? Fast queue based on set. Can we use set to implement a fast queue in JavaScript? And why is Google so slow? What's going on? Is this running in the background causing some sort of problem for Chrome? My Chrome is problematic, to say the least. All right, so our guards went up to 1100, so that's interesting. It took forever to execute, but that's probably because we're doing index off on a 100,000 item array a million, 500,000 times. Where's my JavaScript window? I mean, my browser window. Hello. There it is. Values set may only occur once. It's unique. That's collection. You can iterate through those. Set. The problem is I don't know if set does something bad, like something messy on the inside. Has method checks set using an approach that is on average quicker than testing most of the elements that have previously been added to the set. It is on average faster than area product includes method when an area has a length equal to the set's size. But is it as fast as an index? All right. I'm optimizing things that don't need optimizing at the moment. If I wanted to optimize this, I would have an index and I would keep a order of keys in a queue. So as we're shifting, we'll pull out which element we shifted and, do something with that. Okay. I think this is where I'm going to call an end to it. What I would have liked to do is I would have liked to go further into what each level means, because it's still a bit unclear in my head, but this could be just because it's late right now and my brain isn't thinking. But the idea is basically level 0 means prevent accidental duplication. So we probably want to time out of level 0 relatively quickly. So level 0 is where our riskiness happens with interfering with classroom action. So my primary concern is to say, okay, we want to prevent accidental duplicate events. So we want to time it relatively fast. Except what I saw earlier with having 2-3 minutes apart, actually those we probably want to include, because the idea is that if multiple students in a classroom follow along with a puzzle solve, we want to count all their solves, basically. If they're on the same IP, which could be fairly common in a classroom setting, university setting, that kind of thing. So what I really should look into now is, first of all, we got to go down on our time here, on our size here. And I want to count how many times we're going from guard level 0 to guard level 1, right? Well, we know we go every time. Yeah, we don't have a delta time for guard level 0. Yeah, we don't have a delta time for guard level 0 at the moment. I'm just realizing. Hey, Keith. Thanks for stopping by once again. Really appreciate you guys being there. I'm just thinking, because right now I'm treating guard level 0 as if it's the first event, but it's actually the second event, right? Because if we're preventing this, and the first event was like half an hour before, it's already likely that this is an honest thing, right? So we almost do want to include the timestamps on the queue events as well, which is a little unfortunate. So we're adding to the queue, we're checking the queue, and then we're creating the guard. Check queue. Currently returns true, but we can return the index. So let's try something here. First of all, let's see how long this runs. Okay, doesn't take too long, that's fine. Then what we're gonna do is in create guard, we're gonna look up the item. So how many create guards are happening here? We end up with 47. So a couple, right? If we look at check queue for this pair, what do we get? We'll get a number. And if we index that into the queue, we should get our queue items, right? Including the timestamp, which is on element 2, i.e. the third element, right? And then we can do... this should be older, so it's smaller. So if we subtract that from our current timestamp, we get these. And if we divide this by 1,000, right, and refloor that, this gives us our seconds, right? We are a couple of braces short here, I believe. So this should be our seconds, and that should tell us, you know, problem, not a problem, yada yada, right? If I divide this by 60, this should get us minutes. So here now we can say, okay, what's our timeouts for level 0 to level 1 transition? So for example, you know, so let's delta t equals yada yada. It's just this. So we have delta t, but we also want to now show this and dt, just to have a visual sort of double check, right? So for example, here it's 13 minutes. So this timer was 1:17 in the afternoon and 1:31 in the afternoon. So yeah, 13 minutes apart. Likely a software glitch where they opened the puzzle again later on or resolved it by messing around with it or whatever. But I actually would want, I'd rather count this twice, right? It's the short ones that are like a minute or less, right? And you can see there's quite a bunch of those. So we definitely want to keep those on level 0. Well, no, the short ones we actually, yeah, no. So the short ones we want to not count double, but we want to keep on level 0. The long ones we might actually want to just time out and say, hey, you're not even in level 0 yet, right? Basically counting them as if they didn't happen, right? And I wonder if create guard and update guard should be treated the same way. Because create guard happens where exactly? It happens after check queue. So we do create, we check the guard. If the guard, yeah. And check queue returns the index. So we don't need to do this again. Yeah. Okay. All right. So I'm realizing there's still some complexity there. These short numbers I want to prevent. And then they go to level 0. The long numbers I want to actually, they don't even go to level 0, right? So there's a timeout where we are simply saying, you know what? Never mind. You don't get a guard set at all, right? So we need, for level 0, we need a threshold, right? We need to say, okay, level 0 guarding only happens if you're within 5 minutes or 10 minutes, right? Because, I mean, it might even have to be relatively short. No, we do go to level 0. We don't proceed from level 0, right? They still go to level 0. And at level 0, they might still get counted. So we do actually need to have the delta time as a count, don't count kind of thing, right? So we kind of want to have a threshold. So let's say, and this is in milliseconds. So if delta t is smaller than, so let's say it's smaller than 60 seconds. Or let's say smaller than 3 minutes. Smaller than 3 times 60 times 1000. Right? And then we'll do console.log. Skip count. Right? And then let's not do this. Am I good on the races? Am I good now? Ooh, what the heck? Yeah. So, man, I type fast and I don't think enough. So we skip these because they're under 3 minutes. All right, and then else on these, we'll just say do count. So now we'll have do counts at 38 minutes, at 4 minutes, yada yada, right? These are in minutes. 60 seconds, 1000 milliseconds, 60, yeah. So these are minutes. So at 4 minutes, we count it. 38 minutes, we count it. So if we're say, okay, at 1:55 and 2 o'clock, we'll count it. Because that's the sort of classroom scenario that I want to be able to count. Now, when it comes to additional ones, now we're in level 2, 3, 4 territory. We'll have more or less strict requirements, right? So I think, you know, level 0 or level 1 or whatever will go up to level 50 or whatever. You know, we'll just count how many hits we get, right? And we don't call them levels, we call them counts. And maybe we don't go up a count, maybe we ignore how many counts there are. I don't know, like I'm thinking, can I leave them at a certain level? It's like, okay, if you get a count in every 3 minutes, you'll just don't go up a level, right? But not exactly, because you want to be able to get up to 50 counts in on the bottom levels before you go into, you know, complete block territory, right? Which means that a spammer could get in 50 or whatever. The thing is, once they exhaust the 50, the timeout gets much bigger, you know. So now suddenly, okay, if you get more than 50 in like an hour, i.e., or the separation of 2 classes, because one of the cases we're looking at is like if we have 2 classes back to back, playing the same puzzle with 50 students each, can I make a way to count them all without opening a door for a spammer to just hit it thousands of times, right? And of course, if a spammer figures out the exact algorithm, and I'm talking about it here, and it should be public or it won't work properly, it means they can simulate this scenario over and over, right? So they can say, okay, you know what? There's 24 hours, you accept 50 submissions per hour, so I'm gonna pretend there's a class happening from this IP address every hour of the day with 50 students solving the same puzzle, right? So now we have 24 times 50, so that would say, you know, 1200 increments per day, right? So to get their 40,000 increments, they can do that in a month and a half. So if they really care about incrementing that, they can just run the script in the background and it just simulates a classroom, right? So I do need something that slowly brings this, like as the levels go up, it accepts certain things. So it might accept 100 in 2 hours, but not 150 in 3, you know, that kind of thing. So that's the thing I need to fine tune. I have to figure out a way of expressing that simply, but with all the power that I need. But I think I do need to track the DT in the queue. I would have preferred not to, because that's just data that I'm writing in here. And I guess it's not expensive because it's like just date.now, but it's still a instance of date on each of these hits, right? But But in the end, there's 22,000 in a day. It's not the end of the world either. Or we'll skip it. If we skip it, then the second hit will not count. But then there could be a presumption that in a classroom setting, you would have more than 2 hits. So if we don't count one of them, it might still be okay. It feels like I'm trying to squeeze 2 different functionalities in there. Like I'm trying to prevent the double submissions, allow multi-submissions, and then prevent spam submissions. And that's what makes it tough. And I don't know why I'm doing this to myself. I could have just done the spam prevention. The classroom scenario is probably not a big deal, and I probably shouldn't worry about it. And I probably shouldn't go up to 50 either. Even if the class is large, I should look at the timing more carefully. You know, make sure that submissions within seconds don't work, but submissions within 5 minutes or 10 minutes work. And then assume in a classroom setting, the submissions wouldn't happen all within the same minute after all. Yeah. What I'm trying to do is might not be feasible. It might not be a good idea. I might weaken the spam prevention too much while still breaking the classroom setup and also not fixing the technical double submissions, right? So I need to be a little bit cautious that I don't make a system that doesn't do any of the 3 tasks well, rather than a system that does one of them really well, you know? Killing the double submissions would be relatively easy. Killing the mass spam would be relatively easy. Filtering out the classroom setting is quite tricky. And I might be better off just having some other... Well, no. I can have a method to bypass the spam protection because that method might be accessible to the spammers as well, right? So that's always the tricky bit. Anyway, I feel like made pretty good progress. I think mechanically this is already really simple and I can complete it from here. There's a bunch of optimizations I can do if I want to. I don't necessarily think it's necessary. I think if I keep the max queue length to 1,000 or 2,000, then the index off time doesn't really matter too much. I mean, this is just still a second to process 50,000 rows. And I think a lot of that is really the processing of the files and stuff. Check rows. So if we just look at the time to process the rows, and that's basically 2 days worth of work, roughly. So check rows takes 256 milliseconds, right? So this would take up 100 milliseconds of processing per day, which is, you know, nothing. So I shouldn't worry about that. All right, I think I'm gonna call it a day here. It's super late, and I'm keeping everybody awake when we should be having lunch. In the meantime, thanks for hanging out. I gotta finish this quickly because it's not really an important feature, but I want to put it in. And it gave me an opportunity to look at some parts of the system. Like I realized, looking at this stuff, I'm realizing that I'm writing the files, the JSON files, every time a counter gets updated. And there are 2 kinds of files that I'm writing. And one of them is fairly big. So there's this counter info file. Ooh, yeah. And the counter info file, God, so many counter files. Geez, I thought I got to the bottom of the list. Here we go. Yeah, these files. Ooh, I shouldn't have done that. Open archive. Yeah. Well, this file. Yeah, this. Ooh, okay. Yeah, 49 megabytes of JSON data. And I'm writing that 23,000 times per... I think it's killing my... Oh, okay. Yeah, so as far as I can tell, we have a set counter val, we have a save counter data, and as far as I can tell, save counter data here is not debound. Oh, no, wait, it is throttled. I'm an idiot. Okay, so I've done this already. So we're throttling it. min-max on the options, which means we might tune them. Save throttle minimum. So it saves it at least once every 10 seconds. And it doesn't not save it more than every 30 seconds. This, for example, could easily go bigger. But I also shouldn't be writing that file. Like, that file, it's ridiculous that I'm writing that. I'm trying to remember what counter info even has. So if I do this here. Oh, I'm hearing gasping from behind me. That scares me. Can I open this with just regular notepad? Yeah. What does this keep? Oh, it keeps all of the puzzle data. Oh, why? Why am I doing that? Oh, that's terrible. Yeah, I need to fix that. I'm just realizing here it's has long puzzle IDs in here. Which is really bad. I gotta look into that. Why am I doing this? I know why I'm caching that in memory, but why am I writing that to the disk? Terrible. Okay. Anyway, yeah, there's some gremlins lurking under the bonnet. I need to get sorted before the server blows up. All right. In the meantime, thanks for watching. Thanks for hanging out. And take care. Have a good rest of your day.